Lesson from Module 12.3 is distance between 2 points. So the distance formula is what we're going to be working with in this module. And the distance formula is distance equals the square root. In parentheses, you're going to subtract your x values, x2 minus x1, and square it. And then add it to y2 minus y1, and then square that value. And then when you're all done, you're going to find the square root. So the first thing we're going to do is tell whether our lines from these points are vertical, horizontal, or neither. Okay? So when we look at these points, if we have y values that are the same, let's add that to our notes. Y, whoops, guess I got an eraser instead. Y is the same. We know that our line is going to be horizontal. So let's just take a look at that. So if I'm graphing 2 points, right, on a line, and my x is changing, but my y is staying the same, right? My y, let's just pretend it's 2. And my x value's changed, right? My x could be 3 and negative 3 maybe. We'll just estimate there. We know that that's a horizontal line. Okay, now, if my x values are the same, what sort of line do you think we'll have? The y is the same as horizontal. So if x is the same, we're going to have, yes, a vertical line. So let's just look at what that would look like. So let's say my x was 3 and my y is changing. So that gives me a vertical line. So we're going to use that information to help us answer these questions. So we're going to tell whether the points given are the endpoints of a vertical line, horizontal, or neither. So if we look at this, we have y values that are the same, so we know that line is going to be horizontal. On the next one, x is not the same and y is not the same, so that one is going to be neither. We look at our next problem, our x's stayed the same. They were both 0, right? So we know that that is going to be a vertical line. And then the last one, they're all the same. It's actually going to be the same point. So that's going to be a neither. That's not even a line. Over 3, up 3 is just a point. It's one place. So that's not even a line. It's just a point. Okay, so now we're going to practice using this distance formula on questions 5 and 6. I'll use a better color here for you. So I'm going to start by writing the distance formula. Make this nice and big so we can see it. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to fill that information into the equation. So if we look at our ordered pairs, this is our x value and our y value, right? X and y. I can call this one, and this is the second one. So I'm going to fill those into my equation. So instead of x2, I'm now going to use a negative 0.4. And I'm going to subtract from that my x1, which is 0.5. Then I'm going to add my y values. So I start with my second one, which is a negative 1.2 minus 1.3. And then I'm going to square both of these values. Okay. So now I'm going to start simplifying. So here I have a negative 0.4 plus a negative 0.5. So that's going to be 0.9 squared. Plus, this is going to be like plus a negative 2. Negative 1, this is still negative. Negative 1.2 plus negative 1.3, which will be negative 2.5, and I'm going to square that. Okay. So when I square those values, it's going to get rid of the negative sign. So if I square a negative 0.9, I'm going to get a positive 81/100. Plus, I'm going to square negative 2.5 times negative 2.5, and you might want to use a calculator for that. Make sure you always have a calculator out during notes. And you get a positive 6.25. The next step would be to add those two values together. 0.81 plus 6.25, and you get 7.06. Now next year when you take math with Mr. Durfee, he might just have you leave it as a square root, okay? But we're going to round these to the nearest hundredth. So in our calculator, we're going to put second square root 7.06 equals, and we're going to round to the nearest tenth. So our distance is approximately 2.7 units. But next year, again, remember, you might leave it as a radical, as a square root. Okay. All right, let's go on to the next one. I'll do this one in a different color. Let's do it in the red. Okay, so we write the distance formula. Distance equals, again, we're going to have x2 minus x1. We're going to square that. We're going to add it to y2 minus y1, and we're going to square that. Okay, so now, again, we're going to look up at our numbers. We're going to fill them in. Our x values are 6 and 2, right? So we're going to take our second x value, which is 2, and we're going to subtract 6. Then we'll square it. Now look at your y values. You have a negative 4 and negative 3. So negative 4, negative 4 minus a negative 3. And then you're going to square that. Just filling in the information that's given to you. Now I do everything in parentheses. So 2 minus 6 is like plus a negative. So 2 plus a negative 6 is a negative 4. You're going to square that. And then I'm going to do plus a positive here. So you have a negative 4 plus 3, which is a negative 1. And you're going to square that. So again, inside parentheses, negative 4 times negative 4 gives you a positive 16. Plus negative 1 times negative 1 gives you a positive 1. So now you have d equals the square root of 17, which may be as far as Mr. Durfee wants you to go next year. Or if you actually find it, again, you're going to use your calculator, second square root button, 17, push equals. And you're going to get 4, and if we round to the nearest tenth, it's 1, 2, 3, so it's just going to be 4.1. And we're going to label that units. That's how to use distance formula. Let's try a few more examples from your book. So turn to page 390 for guided practice. Page 390. Again, we're on page 390 in your workbooks. Make sure you have your calculators. Pause the video if you need to. Okay, the first one says approximate the length of the hypotenuse of a right triangle to the nearest tenth using a calculator. So on problem 1, those points are graphed for us. Okay, we're trying to find the distance between the hypotenuse here. Okay, so we can count all the side lengths up on here, and then we can find the hypotenuse. So if I count the distance, I have 1, 2, 3, 4, 5. So that's 5 units. If I count my other leg, it's 1, 2, 3 units. And then I'm going to label this C. So I can use Pythagorean theorem in order to find the distance between those 2 points. Okay? So I can actually say a squared plus b squared equals c squared to solve that one. So 3 squared plus 5 squared equals c squared. 9, 3 times 3 is 9, plus 25 equals c squared. Add them together. 34 equals c squared. The last step is to find the square root. So you're going to use your calculator, second square root, 34. And you're going to get 830, so you're just going to round to the nearest tenth. So c is 5.8. And we're going to label that units. 5.8 units. Okay. Now the next one, you could graph the points just like we did right here. But you'd have to use a separate sheet of paper. Or you can actually use the distance formula for these 2 points. So I'm going to show the distance formula, and maybe I'll quick show too how to graph them for those of you who like to do it that way so that you can see. So in the distance formula, my ordered pairs are 3, 7, and 15, 12. Okay, so I'm going to write my distance formula down. Okay, and that's in your notes. Refer back to it. Distance equals, again, you're going to subtract your x values, x2 minus x1, and square it. And then you're going to add it to the difference between your y values, y2 minus y1 squared. Okay? So in that formula, I'm going to fill in my x's as being 15 minus 3. Then I'll square that, plus my y is 12 and 7. 12 minus 7. Okay, and I still have to square that also. So just using these ordered pairs that were given to you. This is x1, y1, x2, y2. You just fill them right into that equation. Okay, pause if you need to. So now the next step, I'm going to start simplifying this. Okay, so I'm going to do everything inside parentheses. 15 minus 3 is 12, so I have 12 squared. Plus 12 minus 7 is 5, so I have 5 squared. Okay, so this is just like Pythagorean theorem. These are your shorter legs, right? Finding the distance between those points. So distance is going to equal 144 plus 25, and then I'm going to find the square root of that. Okay, so 144 plus 25 gives me 169. Okay, so D is going to be the square root of 169. And that might be one you still know. If not, go ahead and use your calculator. Second square root, 169 is going to give you 13 units. Okay, so that's using the distance formula. Okay, if that's confusing, let me write that up here, 13 units. You can always graph it, okay? I'm going to pull up some graph paper very quickly here. Okay, I just pulled some graph paper up from the internet, and you can do so too. Print some off if you want, or let me know if you need to pick some up someday at the school. So I'm just going to draw this line being my first quadrant, okay? So this point we just did, those ordered pairs were at 3, 7. So I'm going to go over 3, up 7. 1, 2, 3, 4, 5, 6, 7. There's 1 point. And the other one is over 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here's 15. And I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm trying to find the distance between these 2 points. And that's going to be a hypotenuse. Because what we're going to do is we're going to make a right triangle using the lengths that we know. Okay? So we know we can count how far it is between this point and this point here. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 units. And then I can count up 1, 2, 3, 4, 5. 5 units. And these are the same numbers we got using the distance formula. So then we're going to find C. Okay? So we can find that hypotenuse using Pythagorean theorem. A squared plus B squared equals C squared. So we get 5 squared plus 12 squared equals C squared. Same numbers we were using in the distance formula, right? 25 plus 144 equals C squared. So we get 169 equals C squared. Find the square root, same thing we just did, C equals 13. So the Pythagorean theorem can be used also if you graph the points. You can use the distance formula because it's the same thing as Pythagorean theorem. It's the same concept. Okay, let's go ahead and move on to the next question. Okay, the next question talks about planes. It says a plane leaves an airport and flies due north. 2 minutes later, the second plane leaves the same airport, flies due east. The flight plan shows the coordinates of the 2 planes 10 minutes later. The distance on the graphs are measured in miles. Use Pythagorean theorem to find the distance shown between the 2 planes. So in this case, we can just count them. So from the airport, which was at 1, 1, and now we're at 68, 1, we need to find the difference between 68 and 1, which is 67. So this plane that flew east went 67 miles. Now if we look at the next plane, this one went north 80 miles but started at 1 mile. So we have to subtract 80 minus 1, so we knew this one went 79 miles. So we need to figure out how far they are apart, our C value. Okay, so let's go ahead, I'll do that over here, and use Pythagorean theorem. A squared plus B squared equals C squared to figure out how far apart those planes are. So I'm going to use my shorter leg being A, so 67 squared plus 79 squared is going to equal C squared. Okay, so we're going to take 67 squared, which is 4,489, plus 79 squared, which is 6,241, and that's going to equal C squared. Now I add those two values together, 4,489 plus 6,241, and I get 10,730 equals C squared. Now again, all I have to do is find the square root, and I will know what C is. So second square root, put in 10,730. Push equals. Again, let's round to the nearest tenth. So we get 103, and then it's 0.5857. So we look at that 5, there's an 8 after it, so we're going to round it to 6. So it's 103.6 miles. So on that blank, you're going to write 103.6 miles. Okay, so we're going to describe the two ways to find distance between points on the coordinate plane. The two ways we did it, we're drawing the triangle, like right here, and using our distance formula, right? So let's say, I'm going to write it down here just because it shows up better. We can draw a right triangle whose hypotenuse, whoops, I put holes instead of whose. Whose hypotenuse is the segment connecting the 2 points and then use Pythagorean theorem to find the distance. Okay, and the other way that we said was to use the distance formula. Use the distance formula. And of course, you're going to fill in your x and y values. But we'll just put use the distance formula. And that is it.